So what we see a lot of are word problems with graphs. So here's a word problem with a pictograph, and let's think about how we could support students in solving this word problem. The word problem says, the graph shows the number of pounds of plastic the Keller family recycled for 5 months. Based on the graph, how many more pounds of plastic did the family recycle in July than April? Now, when we have graphs and word problems, one thing that's helpful to do straight away is look at this key and go ahead and label this graph. So this key that says that each cylinder means 20 pounds. So I'm going to go ahead and label March. So that means that March, I'll go ahead and write it right here, would represent 50 pounds of recycling. April would represent 80, so I'll go ahead and write that right there. What about May? Let's see, 20, 40, 60, 80, 100, 120, 130. Whew, May was a big month for that Keller family. Then we've got June, 20, 40, 60, 80, 100, 120. And then July. What do we have in July? 20, 40, 60, 80, 100, 120, 140. Wow, even more than the other months. So now that I have those labeled, if I need that information by month, it's just very easily accessible. So now I've got a word problem, and I think, well, whenever I see a word problem, I'm going to UPS check that problem. Let's understand this problem by reading it. How many more pounds of plastic did the family recycle in July than April? So in this problem, I have to focus on the number of pounds that family recycled. I'll go ahead and underline that right there. And here are some of the data related to pounds that were recycled. So I have a pretty good understanding of this problem. Now it's time to make my plan. I'm going to ask myself, is this a total problem where parts are put together for a total? No, I'm not combining July and April. So then I ask my question, is this a difference problem? Are amounts compared for a difference? And maybe I use that gesture to show a greater amount, a lesser amount, and a difference. And I say, yeah, I'm comparing those two amounts. Once I decide that I'm going to solve this as a difference problem, I'll go ahead and write in my difference equation, just like you see here. I could also draw the difference graphic organizer. That would work well as well. But now I've got my plan. Let's solve this as a difference problem. So in, let's see, in July then April. So July had 140 pounds, April had 80 pounds. Let's see, July is a greater amount. I'll go ahead and write it right here. I'm going to check that off so I don't use that again. And 80 is the lesser amount, so I'll go ahead and write that right there and checked it off so I don't use it again. And we have to figure out the difference. I'll go ahead and put in my signs. Let's think about how we should solve this. That question mark would equal 60, and what would be a good label for that? Well, I think pounds. That would be an excellent label for this word problem. So what we did is we solved the problem, and then we want to go back and check our work. 60 plus 80 does equal 140. Hurrah, we did it. So there we used our word problem attack strategy with a focus on the word problem schema to help us set up and solve this problem with pictographs. Now that was a lot about word problem solving. In many of the other modules for the Kansas Math Project, particularly the module on addition and subtraction and the modules on multiplication and division, you'll see a lot of this word problem stuff. So that was just one example of how we could use our word problem savvy, I'll say, to set up and solve this problem with pictographs. All right, let me erase. I will magically be back to do another word problem with a graph. Now let's work on a problem with a bar graph. I see a word problem, that's that mix of numbers and words. I know I'm going to attack it with my word problem attack strategy. But before I do any of that, I'm going to go ahead and label this graph just so I have this information at my fingertips. So here I can see that Jeff answered 6 math problems correctly. Amber answered 24. Go ahead and write that right there. Gary, they answered 9. Let's see, Farah answered 15. And Steve answered 21. All right, that is great. I'm glad we have that at our fingertips. So now I see a word problem. It's a mix of numbers and words. And I think to myself, I need to UPS check this problem. Let's understand the problem by reading it. The bar graph shows the number of math problems each of 5 students completed during math class. Which list matches the data in the bar graph? So we have to take this information from the bar graph and match it to these lists. So I have a pretty good understanding of this problem. Now, what's my plan? Well, my plan is to look at each of these data points, and I'm going to see if it matches this list. And if it matches, I'll give it a check mark, and if it doesn't match it, I'm going to cross it out. All right, so let's go ahead and see. Jeff, 6, that's good. Amber, 24. Gary, 8 and 9. Oh, that doesn't match. I'm going to go ahead and cross that out. Let's go to the next list. Jeff, 9. Jeff, 6. Oh, that doesn't match. I'm going to go ahead and cross that one out. What about here? Jeff, 6. Amber, 24. Gary, 9. Farrah, 15. Steve, 21. Okay, cool. I'm just going to check this one just in case. Jeff, 6. Amber, 21. Oh, nope, that's not correct. I'll go ahead and cross that out. So my plan was to cross them out, and I solved it, and then I want to go back and check my work. I may double check that this list represents this data here, and then ta-da, we have checked our problem. So that is an example word problem with a bar graph that students might be expected to set up and solve. This one wasn't asking students to take information and manipulate it. Instead, students were comparing their original data source to the bar graph and seeing which of those was the same. So let me do a quick erase, and then we will continue. Now here is an example of a line plot that's presented within a word problem. There's a lot of stuff going on here, so I need to get out of the way. So here I see a word problem that's a mix of numbers and words. And anytime I think about a word problem that's a mix of numbers and words, I want to attack it. Here with my attack strategy of UPS check. Let's understand this problem by reading it. Students pushed toy cars to see how far they would roll. The table shows the number of cars that rolled different distances. Which dot plot matches the data in the table? So I've got a general understanding of this problem. I need to connect the data to the line plot or the dot plot. Now it's time for me to make a plan. Here I'm going to maybe think about organizing this information according to a number line and drawing my own line plot and then seeing which one matches up. So here I could say, all right, I'm going to draw my number line and then I'm going to compare my number line to the dot plots, or I could just look at those dot or line plots on their own. So let's think about which of these matches up. So I can see one car went 1/2 of a foot. So I can see that this second line plot and the third line plot, that does not accurately represent that statement. Let's look at another thing. I know that 2 cars rolled 1 foot. Can I check and make sure that's the same on both of those line plots? Yes, I see that that's true. I can see that 0 cars rolled 1.5 feet. But if that's true, then A is not correct. So that leaves me with D. And then I do want to check that all of the data in D is correct. So I could go through and check all of the rest of the data. And then finally, I want to go back and check my work to make sure that D is the correct answer choice. So now it's time for you to push pause, and I want you to think about how do you help students understand word problems with graphs in your classroom?